Okay guys, let's take a look at a very simple network topology. We have two computers connected to a layer 2 switch. These are both on the same VLAN, by the way. This is just VLAN 10. We can take a look at the switch. We see that port 0 and port 1 are on VLAN 10. So these are in the same VLAN on the same subnet. So let's talk about the communication when PC1 wants to talk to PC2. PC1 does not know PC2's MAC address right now, so he's going to have to go ask for it. So he's going to send, let's say I want to ping PC2 10.1.1.2. Since he doesn't know the MAC address, he's going to have to send an ARP out. That ARP will hit the switch, and it'll be flooded out all the ports on the switch that are on the same VLAN. So since this PC is also on VLAN 10, the ARP will traverse, be broadcast out to PC2. PC2 will be listening. He'll say, oh, you're looking for 10.1.1.2, that's me. He'll send back the MAC address. He'll say, to get to 10.1.1.2, you're gonna look for this MAC address. We can demonstrate that. We'll bring up a console, and then we'll start a PCAP or a Wireshark. So let's start our Wireshark on this link. We'll wait for this to fire up. And now let's ping 10.1.1.2 from PC1. And there we are. So we see here the first packet that goes out is that broadcast packet. And this is PC1 reaching out to the network saying, who has, literally that's what it says, who has 10.1.1.2? Tell 10.1.1.1. So let me know who 10.1.1.2 is and let 10.1.1.1 know. So 10.1.1.2, we get a reply and it says is at this MAC address. So now that PC1 knows the MAC address of PC2, he's able to send those ICMP echo requests, and then we get the echo replies back. So he's able to ping after that. Now to take it a step further with a layer 2 switch, as soon as any node connected to that switch sends traffic, it's going to make note of the MAC address, and it's going to keep it in the CAM table or the MAC address table, which won't time out until 300 seconds of inactivity on that port. But the switch will eventually learn, everyone who's talking on that switch, will learn and keep a record in the table of their MAC addresses. This way, when PC1 sends to a specific MAC address, the switch already has it in its CAM table or its MAC address table, and it doesn't need to flood it out all ports. It'll say, oh, I know where that's at. That MAC lives on this port, and it'll send it over to PC2. So at a super high level, that's how these two are talking. Let's take it a step further and let's talk about data encapsulation. So this is what actually happens. Let's say you're sending an email from Outlook, you hit enter. There's a lot of stuff that happens behind the scenes with the TCP stack where it has to go through the different layers, and it's encapsulating the data, if you will. So let's take a look at that process. Hello. Okay guys, so data encapsulation. We're gonna look at the OSI model. It's also handy to reference the TCP model when you're looking at this, but this shows all 7 layers of the OSI model. So we have the application first, followed by presentation, then it'll get sent down to the session layer. For the session layer, it sends it down to transport layer, transport down to the network layer. The network layer hands it off to the data link layer, and then the data link finally sends it off to that physical layer. So this is the OSI model. If you guys aren't familiar with it, there's a couple ways to help you remember this. If you want to start at the top with application, that's technically layer 7 at the top, but you can use an acronym, all people. So it'd be all people seem to need data processing. That's a good way to memorize it. That's not the way I did it. I actually started from the bottom and used a different acronym. Please do not throw sausage pizza away. Either way works, whatever's going to click better for you as far as memorizing that. So that's the OSI model. And when we talk about data encapsulation, the encapsulation process literally worked its way down this stack. So let me show you what I mean. So the application will hand it off to the presentation layer when it's ready to send that data. The presentation layer is gonna be where the encoding and the compression, and if you're doing any encryption, that's all gonna take place there, right? So the presentation layer really presents it or gets the data ready for presentation in a standardized format that comes with the encoding and the compression. Once it's traversed the presentation layer will hand it down to the session layer. So the session layer is where a session ID will be attached to the data. And at this point, you can still think of the data as one whole big block of data at this point. So once the session layer has done its thing, it hands it down to the transport layer. But before we get there, I'm going to show you what the PDU or protocol datagram unit looks like. And just think of that as, I don't want to use the word packet because that's not really correct, but think of it as the data block or the data itself, what it looks like at each layer, right? So at the session layer, it's just the data still at this point. Again, from session, we hand it down to the transport layer. And this is where the data is broken up into smaller chunks or smaller blocks, if you will. And this is where the data gets its first header. So it's going to get a TCP header. And remember, when we talk about transport layer, this is layer 4. This is where we start talking about things like ports and protocols. So you're going to get that TCP header, and that'll include source and destination ports, sequence numbers, and some other information. But really, for all intents and purposes, think ports at this level, right? So layer 4, you start talking about, port 80 or 422. We start to get a realization of what protocols we're using. What is this application doing, in other words? So at that point, you'll see we have a TCP header and we have our data. And this is where we start referring to the PDUs or the protocol datagram units as different terminology. So at this point, a lot of times you'll hear at the transport level or layer, it's referred to as a segment. And then if you're using UDP as a protocol, they'll call it a datagram. But think segments, think ports, think transport layer here, layer 4. All right, guys, so once we're done with the transport, it's actually going to hand that down to the network layer. This is layer 3, right, or level 3. So this is where we start talking about IP addressing. When you think of layer 3, you're thinking IPs. So add layer 3, the network layer, we add another header. We basically encapsulate what we had before inside of this. We tag another header on the front of it. So we're just going to keep adding to this data with headers and eventually a trailer as well. But you'll see it's the same theme as we go along here. So at the network level, another header is added, and this includes the source and destination IP address, and this is where we refer to it as a packet. So layer 4 was a segment, layer 3 is a packet. Now we're going to move down to the data link layer. And again, another header is added at this point. And layer 2, we're talking about MAC address, data link. This is where another header comes on, and again, think layer 2. So it's going to be the source and destination MAC address. So as you see, now we have the frame header, which is the layer 2 header, and that's encapsulating what we had before with the layer 3 and the layer 4 header at the data, and now we've added what they call a frame trailer. So that frame trailer works for a couple reasons. It indicates the end of the frame, lets you know, hey, this is the end of the frame, and it also serves for error checking. So it's going to check, make sure there's no errors in the frame. So that's what our frame looks like at this point. We've got 3 headers, we've got data, and we've got a trailer. And then from the data link layer, guys, it's going to go all the way down to that layer 1 physical. So this is where your NIC is going to do the modulation, demodulation. It's going to take the data from that frame and it's going to transform that into signals. And today that's going to be binary. So you're talking ones and zeros. That could be in the form of electricity, light, radio waves, just depending on your media. But just think of it as, sending it down to the Cat5 or Cat6 cable. And it's going to send that across as electronic pulses. It'll be representative of ones and zeros. So at that level, we think of things as bits down at that physical layer. And really, guys, this is the encapsulation process. So here we have the the bits of data moving across the wire in bit format, ones and zeros. And then the opposite is true. So I can make another slide that would help you guys, but just think of it, the same thing coming in backwards. So the receiving computer would receive all these ones and zeros. It would bring it up to that second layer. It would check that frame header. And then once it checks everything out, it looks good, it's going to peel off that frame. And then it's going to be left with a packet. So it's going to ditch that first header in that trailer. And then it's going to be dealing with the IP header, TCP header, and the data. It's going to do its IP checks there, peel off that packet. So the first header is gone. Move it up the stack to the transport layer. Checks there for the TCP header information. If everything looks good, it moves the data on up to the session, presentation, application layers. So it's kind of a reverse of the encapsulation for the de-encapsulation process. So I just thought this would be helpful for you guys to understand what actually happens when you hit enter and send an email or whatever you're doing. There's a lot of things that go unrecognized and unappreciated, quite frankly, when it comes to the transmission of data across even simple networks. So hopefully this was enlightening to you guys. If you'd like me to do another video to dive into any of these layers or any part of this process, or maybe you'd like to see the de-encapsulation process in more detail, please give me a thumbs up and let me know. Drop me a comment. I'd appreciate it. I'm probably going to start a series on very basic network concepts and trying to build up from there as the audience becomes more engaged, hopefully. So thank you guys for sticking around to the end. I appreciate it. Give it a thumbs up, like I said. Make sure you subscribe if you haven't done so already. And until the next time, take care, guys.